start recording. Okay, so evening, everyone. So we are going to be talking about Python. So essentially, we are going to be trying to understand, understand functions in Python. So the first thing is what are functions? The first thing, what are functions? Oh my, where am I? What are functions? There is a reusable block of code that performs a specific task. So what does this mean? We know that we've spoken about different rationale and ideas in Python programming, and then we know that we also know so far that we can group code lines together. We've spoken about block of codes, and then we say that block of code, a code line belongs to the same. You say that a code line belongs to the same block if they have the same indentation in Python. So a code line belongs to the same block if they have the same indentation in Python. And then we know what we call indentation. What is indentation? That four spaces before the four spaces before a line of code. So if I say x is equals to 2, x is equals to 2, and I say if x equals to 2 column 1 2 3 4, it means that x is equals to 2, and then if x is equals to 2 or they have the same indentation line, so they belong to the same block of code. But under if x, you see I have indented, right, by adding 4 spaces. Then I can say print x, and I can further say 1 2 3 4 print x print x. The two print functions, they belong to the same block of code because they have the same indentation line. So if I do this, I can have this. Right. So now let's go into what a function is proper. Sorry. Yeah. So we know what it means for a for code to belong to the same block, right? Okay, so what are benefits of a function? All these benefits are going to make sense later, but for now, one benefit is code reusability. So when you can bundle a block of code together, then it means that you can take that bundle and reuse it, throw it around in your program and reuse it as one, which is what this code reusability is speaking to. And then we have improved readability. So this helps to improve readability because you can study code as smaller components, smaller bits of your program. Then because there are also ways to create a function. These functions have to perform specific actions. So when you name your function according to the action they perform, and then you know what this function does, you can throw them around and it helps reading your code very easy. So you can put code that do the same thing together in your under your function, and then you can name them accordingly. And then another interesting thing that this helps with is modularity, if I can pronounce that. So modularity in the sense that now you've bundled your code together, it becomes modular, right? You can say this is a module, you can have different components as module, and then you can connect them together and use them in whatever format or composition you require it. And then another thing is it makes your code to be easily maintained. So maintenance and testing becomes easy because they are modular. Then you can test and maintain your code as in bits, and then without having to worry. So for instance, you have a function that we have reused several times in your code, then you can take that function and change the function, and then it will be updated across your program, right? So just to be sure, okay, okay. So those are the benefit of a function. So now let's get into the code. Let's get into how do we define a function in Python. So the syntax is simple. To define a function, you use what we call def. This is a reserved keyword in Python, and then the next thing after that is going to be your function name. And then if you want to add parameters to your function, you add parameters, and then you terminate that by a colon. And then everything you write under your function definition has to be at least indented with 4 spaces, 1 2 3 4. So now I can say return 0, and then boom, I have defined the function. So what does this function do? I have a function named function name, and then the function takes one parameter that we are calling parameters, and then it returns 0. So let's define a proper function now. For us to define a proper function, define a proper function, right? So we have a function we are going to call greet, and then it is good practice to make sure that the name of your function connotes what the function does. And then it is because the function performs an action, so it is a good thing to also make sure that the name of your function is what? A verb. Greet is an action word because the function greets. That's why the name of the function is greet. And then want to greet, you want to greet someone, you need the name 1 2 3 4, and then want to say hello, and then want to do this hello. So that is how you define a function. Now
Sorry, sir.
please go on.
Sorry, sir. So why did you put that F before the yellow?
Okay, so
There's a
f.
function F.
Mm-hmm. All right. So f now is a string formatting, is a way of formatting strings that allows you to inject variables into them. Do you understand? So when I could say hello, I could say this is a string, I could say hello, and then once I press enter, you see that it is hello, and I can check the type of this. Okay, what is the type of hello? And then it's going to tell me it's a string. Now if I want to add any other string to hello, I want to say hello Adedamola, I have to do something like this. I want space in between, and then I have to say hello Adedamola, and this is what we call string concatenation. And then I have this, right? But if I want to inject a variable, say I now say name is equals to Adedamola, and that is going to be a string, and then I have hello, I could say this space, one space, and then I can say plus name. But say this name can change, it could be anything, it's a variable. I can also say that this, and then I can put hello like this, and whatever changes is going to be under curly bracket. Whatever changes is going to be under curly bracket. In curly bracket, it's going to be hello, and then it's going to be name. So instead of writing it this way, I can write it this way, and then it's still going to be the same. So it means that when I change the name to Tola, when I run this, it changes to Tola. This is what enables us to do that. Do you understand? Is it clear?
Yes, sir. Yes, sir. Yes, good.
Okay, so let's go back to what this is defining. So we define a function here, and then a function is great. So now the next thing is, how do we call a function? Call calling a function in Python. So we have defined a function here, and then the name of our function is called greet, and then the function takes one parameter, which is name, and then it returns hello, whatever the name is. So now how do we call it to use the function? You call the function using the name of the function, and then this is how you do it. Greet is the name of the function, and then we know that the function takes one argument, which means we need to define an argument that will pass into that function. This argument has to be a string, based on what we have defined, the line of code, the block of code under our function. We know that it is only, well, other data type could work in here, but the right argument or a reasonable argument would be a string, because we need to pass in a name. So we can say that my name equals Charles, and then I can now call my function by using the name of the function and passing in an argument into my function. And once I press enter, my function is called. Right? So I could also say great, and then pass directly the name in here, and I can say this name is dollar still, and then my function still works. So that is how we call a function. Now I could also make this and say result equals great, and equate my function to assign my function to a variable, and then pass a name. Let's say my name still, and then whatever the output of this function is what is going to be stored in this variable. So now once we press enter, based on what we have here, it means that this is what is going to be then stored in this variable, which means if you check the type of result, you see that result is a string, and then once you check the value, you see that it equals to hello Charles. So far, is that clear? All right, thank you. So now let's go to function parameters. So we have different type of function parameter types. Include positional parameters. We have keyword parameters. And then you have default parameters. So we are going to go one after the other, talking about each of these parameters. So we know that parameters are anything you put inside here, inside as argument to our function. So say parameter, this is where parameters go. So all those things we put in here could be positional, it could be a keyword, and then it could be a default parameter. So now let's see what a positional parameter is. Let's see what a keyword parameter is, and let's just go into it one after the other. So explain what a positional parameter is. Positional parameters. So we have our function still, we are defining our function greet, and then we have it takes name, and then we say 1 2 3 4 return my name is name, then this has to be an F string. In this case, name is a positional parameter. Now let's give an example of what a keyword parameter looks like. So keyword parameters, we've spoken about dictionaries, and then we said about dictionaries that each of their values has to be key value pair. So keyword parameter, essentially a good example of that is key value pair being an argument in a function. So if we define a dictionary of numbers that looks like this, and then we say numbers equals, we know how to define function dictionary. 1 matches to 1, 2 matches to 2, and then 3 matches to 3. If you check the type of this, we see that this is a dictionary. This is a dictionary. Now if we define a function, say counting numbers, and then we pass in numbers 1 2 3 4, return numbers. Because this is a keyword, input. This is a, we call this a keyword parameter. So if I call this function now, I call counting numbers, and then I say numbers because we have defined number up there. Counting numbers, that was a mistake, and then we get our keyword argument back. Right, so what is the default parameter? So let's talk about default parameters, and then the default parameter basically speaks to, say, define power, and then we want to say we want to give a function, write a function that returns, you give in two parameters, and then it's going to raise it up to the power of 2. So we input the base number and then the exponent, and then we know that the exponent is 2, and then 1 2 3 4 return base raised up to the power of exponent. In this case, because exponent has a value, exponent in the above is a default parameter because it has a default value. The value could change, but it has a default value, a starting value. So if I call that function, let's say power, because exponent already has a value, I don't necessarily have to enter a value for it, which is, it is now optional. So I could say 4, and then I'm going to get 4 raised to power 2 returned, and then it's going to be 16. But if I can then go ahead and still specify, if I don't want it to be raised to the power of 2, I want it to be raised to the power of 3, I can then have this. There's going to be 4 times 4 times 4. But this is the behavior you get with default parameter, because that is default value. For keyword parameters, it has to be a dictionary kind of parameter, which is what we have here, and then we demonstrated this with this. And then for positional parameters, single valued, and then this is how they come. Now, what is the order of using all of these parameters? So if I have, for instance, I can do type checking, typing in functions. What that means is that, or let's say typing generally in Python, typing means that I can go ahead and say that I want to define a number, and I can already tell you what the type of the number is going to be. And then if I do this ID there is telling you that the value that is going to be saved here is going to be an integer. So when I check the type of the number, obviously it's going to be give me an int. Or I can say name, and then I'm telling you that name type is going to be a string, and then that's to be like name. Then once I check the type, it's going to be string. Now if I have this, I say it is a string, and I input a number, what happens? Python is not strongly typed, so it's still going to allow it, surprisingly. But once I check the name, I have a string, because the value actually determines the value. The value actually determines the type. But when you are in Python, then you are type checking, it improves your readability, and then not that you have to, but it improves readability. So this is what type checking is. So you are matching the type with the value that you expected to be saved in the variable. So we can do the same with functions. So now we have a function, and then the function is still power, and then we have we have one is going to be, no, let's say addition, add, and then there's A, there's B, both being positional argument, and then there's numbers being a keyword argument, and then there's value being a positional argument. And then this goes like the 1 2 3 4, return a raised to the power of a plus b, comma, sum of numbers dot values. Let's hope we don't run into issues, comma 5. Now let's call this. We know that A is 2, A could be 2, B could be 3, this could be number. We know number is declared up there, and there's a dictionary, and then we have this. Now what have I done? Essentially, I come here and then I can type check this and say this is going to be an int, this is going to be an int, this is going to be a dictionary, and then this is going to be an integer. 1 2 3 4, and then I can still go ahead and do everything I did here. And if I define what I define, I still get the same value. So now the point is that the order of things is that 1, the order of parameters are positional always comes first, followed by keyword parameters, and finally by default parameters. Please note this is very important. So we have 15 more minutes. So let's quickly talk about something else, and then this is going to be scope. So scope in functions, we have two types. We have local and then local variables, and then global variables. So what are local variables? If I say definition, I define a function and then it's called func, and then I have this. I can define my function without it taking any parameter. I can say 1 2 3 4, and I say x is equals to 5. This x is equals to 5, x is equals to 5 is local. And I say y equals to 2 3 1 2 3 4. Note, x and y are local variables to the function func. 1 2 3 return x comma y. What does this mean? Now x has been defined, y has been defined. In the global scope, which is anything outside this function, if I try to get x, okay, I've defined x before, so there's a global scope of x, but I've never defined y before. So if I try to get y, I'm going to get an error. But under this function, there's a y variable that has been defined. So if I call this function, I'm going to get 5 and 6. So there's a global, so x here, the x that is defined here, so if I change the value of x equals to 1000 and y equals to 9000, that is not going to change the value of x and y under a function. So x and y in here is a local variable, and x and y that we have defined outside the function is global, and then it is global variable, which means that if I say, I could say that I could define this func comma x comma y, and then I'm going to get different values. So this is a func x and y in our function, x and in which is local to the function, x and y global in our scope. So essentially that's what global variables are. So there are other functions that we could talk about really, and then one here is what we call a lambda function. Lambda functions are interesting, and then the formula is that you have lambda, you have an argument, and then you have expression. So say a lambda function. So this is how you declare a lambda function. You put your arguments here, like the parameter that you pass into the function, and then you put the expression or some sort of formula of what you want to perform on the variable or the argument. So let's say I have lambda, I define lambda and I say z, and then I want z to be raised to power of I want z to be raised to power of 2. Now, how to name this is going to be square root. Let's say call this square, and then we equate this to this. So if I define z equals to 4 now, and I run this, and I see what is our square, how this. So it's always like object like this. We'll go more into it later, and then there are other functions that we could talk about really, and then one is like a map, one is a filter, and then another one is reduce. You have 15 minutes, 10 minutes now. Let me see if we can talk about lambda more. Yeah. So let's do this. Let's define a function. Say we define a function hard, and then is a lambda function, and then it has 2 arguments, and then all we want to do is add. Once the 2 arguments are passed, we want to add the 2 arguments together. Now I could say result equals to add, and then I know add takes 2 arguments, and then it's going to be 2, 3 or 4, and then if I say result, I should get 6. So let's go again and say square. We have a function square, and then is a lambda function, and then it takes just 1 argument, and then the argument is square root, is raised to the power of 2. So I could say result again equals square, and then square takes one argument, and then in this point let's say x is equals to 3, and then we know x 3 raised to the power 2 is going to be 9. So if I say results, I'm going to get a 9. And then now I can go further and say that we spoke about that we could use. So basically this is what lambda function allows us to do, but we see that this only takes normal argument like this. So let's talk about map quickly. Map, all the higher functions allows us to work with lambda. So now what map does, it helps us when we are working with a list and then we want to use lambda to work on this. So we have 1 2 3 4, and then we want to perform this square root function on each of the value here, right? So what we do is that we say squared, squared, that was right, and then we say map, and then we still declare. So let's do it this way. We have square, and then we know that we want to square each of the values, so we say lambda x, and then x is raised to power 2, right? So this is, we want to run each of this function on each of these values. We could do it one after the other and say result equals, or we could say square number 0, and then we have 1, number 1 we have 4, and number 2 we have 9, number 3 we have, okay, number 3 we have 16, right? Another way to do this is for number in numbers, right? We could go one after the other and say 1 2 3 4 square, and then pass in number into our lambda function, and then we get this. But what if we don't want to use for loop, and then we don't want to go in speak each of the number one after the other? One way to do it is we say squared number, and we want it to be a list, or let's start with this. We can use map, and then we pass our lambda function into the map. So we could define the function normally, or we could pass in the function like we have defined up here, and then say function, our lambda function, and then the list that we want to perform an operation on. So once you check squared, you have an object like this, but you can convert this into a list and say this, and then you see your object comes out. So to make this missing, the formula is that you have map, and then map takes your lambda function, and then list of value, or composite data type, right? Which is exactly what we did. To make this clearer, we could explicitly write everything out, and then let's define a lambda function, and then this time we want a lambda function that is going to scale each value in a list by 2. So we say lambda x, and then x is going to be plus 2. That's our lambda function, and then we want a list in this case that is going to be 1 2 3 4 5 6. So now after this is going to become the first time it's going to pick x, it's going to be x 1 plus 2 is going to be 3, and then next thing is going to be 2 plus 2 is going to be 4, and then next one is going to be 3 plus 2 is going to be 5, and then 4 plus 2 is going to be 6, and then 5 plus 2 is going to be 7, and then 6 plus 2 is going to be 8. So if we do this, we are going to still get an object, but we don't want to get object, we want to get the list. So we are going to convert it out of the box to a list, and then we do this right away, and then boom. So we have 3, 4, 5, 6, 7, 8. So we have 3 minutes more. I hope that at least map is clear. We still have filter, and then we still have reduce, and then we can use this on dictionary. That is why I said that it's going to be a composite object. And then we have I think we defined a dictionary up here. I don't know, so let's say numbers 1 1 comma 2 2, and then we want to go and say that we want to find sum of want to say sum of so we go after it, we want to pick the value, or want to say sum of x. So this is not iterable, just sorry. Yeah, so we want to say x dot value, if I get that correctly. I mean, we just want to print the value. We want to get the key, the value of each of that, and then we have 1 and 2. You don't have to specify. So what happens is, if I say for value in this, it's going to pick the value and print it to the screen. 1 2 3 4, print value, and then yeah, sorry, I'm rushing, print value, and then I have this. Right, thank you everyone.